Okay, trig identities. So there's only two things you really have to remember for this. Okay. Let's see. Pen. So when you start on trig identities, the minute you see these, I would always just write down this at the side: sine x divided by cos x is equal to tan x. Okay, that's one thing you want to remember. And the other one is that sine squared x plus cos squared x is equal to 1. Okay, these are the only two identities in National 5 that you really have to know. Okay, so we've got sine, cos, and tan expressed in its simplest form. So we've got sine x times cos x times tan x. So what we're going to do, we're going to substitute this in, okay, because then things are going to start to simplify for cos. Okay, cos x. So I've got cos x on top and I've got cos x on bottom, so they can cancel out, and that's going to leave me sine x times sine x. So that's just the same as saying sine squared x. Okay, it's actually quite a beautiful, something quite nice about that. I don't know why, but yeah, sine squared x. The other way of thinking about it, which I think is quite interesting, is when you actually think about what your SOHCAHTOA. Okay, so we've got SOHCAHTOA. Okay, so sine x is equal to the opposite over the hypotenuse. You know, I'm just going to write that just in case that's not familiar to anybody. So we know that sine x is equal to opposite over hypotenuse. Cos x is equal to the adjacent over the hypotenuse. And tan x is the opposite of the adjacent. Okay, so SOHCAHTOA. Okay, so if we were to rewrite this, sine x, cos x, tan x in terms of this, it would look something like this: the opposite over hypotenuse times adjacent over hypotenuse times opposite over adjacent. Okay, and then you can start to cancel things out. Say, well, there's an a here and an a there. I'll cancel the a's out. So that just leaves me OO divided by HH, which is the same as O squared H squared, which is the same as over H squared. And we know that over H is sine. So that's going to give us sine squared x. Okay, so there are different ways of thinking about it. I think there's something quite nice about the simplicity of this method. But the big point is when you're doing these questions, just remember these two identities. Okay, that's the important bit. Okay, you're trying to put these into the equation. Okay, so in this case it was tan we were getting rid of, and then cancelling out. All right. So in the marking scheme, you're going to get a mark for this first line here, and then you'll get a second mark for finishing off with sine x squared. So actually, even just doing that right away, you get a mark. Even if you don't know how to simplify, just substituting for tan x gets you a mark, 50%. That's really good. Okay, but then knowing to cancel and then write it in the correct terminology is your extra mark. All right. But yeah, I quite like those wee questions. And again, I like this method. Something quite nice about it. Okay, 19a. This is a complete the square. Pardon me, a complete the square question. Okay, the minute you see this, you should be thinking complete the square. Okay, so we've got x squared minus 6x minus 81. So I'm going to write x squared minus 6x. I'm just going to move over here and put the minus 81. Okay. So this bit here, we're going to manipulate. Okay, so the minute you see this, you're thinking complete the square, and we're going to manipulate this first section. So how else could I write that? So remember the little table I like to draw. Okay, what we're going to say is x minus 3 and x minus 3. So what you do is you half this number. Okay, I'm going to half that number. In fact, I'm just going to highlight it because that might look confusing. So this number here, we half. So that would give us x squared minus 3x minus 3x plus 9. Okay. So x squared minus 6x is that bit there. So we've got x squared and we've got minus 6x. So that's good because up here we get x squared minus 6x. Okay. But we've got this extra plus 9, which we don't actually want. So we need to take away 9, okay, to balance out the equation. So if I said in here, x minus 3 squared, I then need to say take away 9, take away the 81 which we already had. Okay, so that's going to give us x minus 3 squared, take away 90. That's our final answer. I'm just going to check to see if it's okay to write it in that form. Yeah, rather than state what P and Q is, that's right. I thought you would lose a mark if you wrote P is whatever and Q is whatever, but just be careful. Some people would write P is equal to minus 3, but it's not. P is equal to 3. Okay, so just be careful. Again, Q is equal to minus 90 because that's got a plus in there. Okay, but no, that's okay. So we're doing complete the square. You're halving this number to get you this bracket in here, but we've generated this number which we don't want. We don't want a plus 9, so we need to take that away. And when we put these two numbers together to give us the minus 90. All right. So state the axis. State the equation of the axis of symmetry of the graph. Okay. So people wonder why we do complete the square, and we do it so that we instantly get information. When we do y is equal to mx plus c, that's a good equation because it lets you know what's going on. Okay, so y is equal to mx plus c, you know where it cuts the y-axis because that's c, and the m's a gradient, so you know how steep it is. So if you're comparing two graphs, you can tell which is the steepest because of the m value. Okay, it's good information, and it's the same with completing the square. Okay, completing the square allows us to instantly see where the turning point is. Okay, so if I draw, let's just say quickly, this is your standard y is equal to x squared graph. Okay, but what we've done is we've moved it left or right with this number, and then moved it up or down with this number. Okay, so forget the minus 90 wasn't there. Okay, say we just had y is equal to x minus 3 squared. Okay, that's just the same as x minus 3 times x minus 3. All right, so we know the root of that is going to be x is equal to 3. Okay, because one of those has to be 0, or both of them. One of them has to be 0 to make y 0. At y 0, it cuts the axis. So we know x is equal to 3. So by doing that, what we've actually done is move the graph over to here. Okay, so that's on 3. And the minus 90 has just moved it down 90 places. So it's ended up, instead of touching the graph here, it's down here 90. Okay, so that coordinate is x is 3, and that's minus 90 for the turning point. Okay, so that's why we express it like this, because it instantly lets us see where the graph is. Okay, if someone shows you this, it's not instantly noticeable, is it? But in this complete the square form, it is. So we know that's 3 minus 90. I just thought it was interesting just to kind of talk around why we do that, And again, it's good you can see here you've got one root in this original one. Yeah, it's just nice and neat. Anyway, I digress. So that's the turning point, but the actual question is saying what is the axis of symmetry? Okay, so the axis of symmetry is obviously going to be, well, it won't be that. The axis of symmetry is going to be a straight line. I'll just draw a line actually. It's going to be a line up here, isn't it? Okay, because if you were to put a mirror there, that would reflect it. That's the same. So what is the equation of that line? Well, it's just x is equal to 3, isn't it? Okay, x equal to 3. So it's interesting when you look at this, the axis of symmetry is just this number with the sign changed. Okay, brilliant. There's no real think about it, it's that number with the sign changed. Easy. And if you want to know the turning point, it'd be that. Okay, just that number with the sign changed, and then that number exactly as it is. Okay, so x is equal to 3. Okay, so don't lose any marks by not saying x. Don't just say 3, x is equal to 3. Okay, so for this one, you're getting a mark for your first part, you're getting a mark for the x minus 3 squared, and then you're getting a mark for the minus 90. And obviously, you're just getting 1 mark for x is equal to 3, but you have to say x is equal to 3. If you just say equals 3, that's nothing. Okay, if you make a mistake up here, you can still get the grade down here. If you had a 4 or a 5, you would still get the grade. So again, if you don't know, if you've not solved that correctly, or you're not sure, just make something up, but then make sure down here you keep that number the same and change the sign. Don't just say I can't do this. Okay, you just make something up in here, and then as long as you do that right. So Your axis symmetry is just this number. Just highlight it. It's just this number in here, but the sign changed. Right, good stuff.